everyone, welcome to Prodigy Educlasses. Today we are going to start with the first chapter of physics of class 9, that is motion. Now, what is motion? Motion is whenever an object moves from one point to another with respect to time. In short words, whenever it changes its position with respect to time. Now, there are three types of motion. The first one is rectilinear motion, the second one is circular motion, and the third one is vibratory motion. What is rectilinear motion? Rectilinear motion is whenever an object changes its position with respect to time but travels in a straight line. To begin with some day-to-day examples of rectilinear motion, we may take the example of a car moving in a straight path, or when we drop a ball from a certain height and it goes to the ground, then it travels in a straight path. You may notice that the ball will never change its position, or it will never traverse in a crooked line or anything other. It will always travel in a straight path. Now we come to the second type of motion, that is circular motion. What is circular motion? Whenever an object travels in a circular form maintaining a fixed point, that is across a fixed point. If we draw a circle, then we may notice that this fixed point will be regarded as the center of the circle. Now to take some day-to-day examples of circular motion, we may notice the motion of a fan. The blades depict a circular motion and the center of the fan depicts the center of the circle. You can also take the example of a spinning top. If we rotate a spinning top, then it always has a fixed point and it rotates in a circular motion. Now we will go to the third type of motion, that is vibratory motion. Now, what is a vibratory motion? Vibratory motion always has or always exhibits its motion in a to and fro movement. Now, to understand this to and fro movement, we may take the example of a pendulum. In case of a pendulum, we have a ball on a string and this ball is known as bob. Okay. Now, in a pendulum, in a simple pendulum, there are two positions, the mean position and the extreme position. What happens in case of a simple pendulum? If we give a slight push to this bob, then it will go from mean position to its extreme position. It will again come back from extreme position to mean position. Again, it will go to this position and again it will come back to its mean position, which ultimately refers that it exhibits a to and fro movement. What is to and fro movement? This is to and this is again fro movement. Now the distance from the mean position, suppose the distance from the mean position to its extreme position is x, and this side also it has to be x. It is always equal on both the sides of the mean position. So if it goes from 0 to x, it again comes back from x to 0. Again it will go from 0 to x and again it will come from x to 0. I hope till this it is clear to you all the types of motion and everything. Now we may go to certain terms that we come across while we study the chapter of motion. The first term that we will come across the chapter of motion is distance. It is a very basic term. You may have heard this in your maths problems or in any kind of problems or any kind of day-to-day life also you may heard about this term. What is distance? Distance is the to explain, I would like to explain with example or something. Suppose a car is moving from point A to point B. We may say that the distance from point A to point B is 10 km. So what is distance? Distance is the passage that an object covers while moving from one point to another point. We need to remember that distance is a scalar quantity. When we go in depth of this chapter, I will explain what the scalar quantity means. For now, just remember distance is a scalar quantity. What does distance have? Distance has a magnitude, a certain magnitude. Okay, so some examples of common distance is very easily available, like a distance between one point to another. You can measure it with a scale, you can measure it with any kind of instruments, you can measure it with any kind of measuring tape or anything that makes a distance. Now the second term that we will come across in this chapter is displacement. What is displacement now? Displacement is a vector quantity. As I said before, distance is scalar quantity, displacement is vector quantity. Now I will make you understand what is the difference between these two words. When there is a scalar quantity, we need to keep in mind that it is all about only the magnitude. And when it is a vector quantity, we need to keep in mind that it contains both magnitude and direction. I would again like to take my previous example that suppose the distance between point A and point B is 10 km. Now to understand this, suppose the car is moving from point A to point B. In case of distance, I will say that the distance is 10 km. But if I have to say about displacement, then I will tell that the car is moving or the car is covering a distance of 10 km in east direction. When I add this certain point of direction, then it becomes a vector quantity. See, I have already written that it contains both magnitude and direction. The third point of difference between distance and displacement is distance can never be zero, but displacement can be zero. Let's take a very simple example of this. Suppose a boy has started his journey from his home to school. Okay, from his home to school, and he again comes back to his home. Like we all know, if we start our journey from home to school, we will reach there and again we will come back. If you don't have any other exam engagements or something. So, in case of distance, the distance will be addition of both the distances. That is, distance will be d1 plus d2. That is the total distance that a person or an object will cover in a course of time. But in case of displacement, displacement is the shortest distance. Okay, these are the key points that we need to remember along with the term. Displacement is the shortest distance. When we say about shortest distance, that is, if we calculate, if we try to figure out the displacement that the boy has covered, then in this case it will be 0. Why 0? Because the boy has started from an initial point, he has reached to a final point, and again he has came back, or he has come back to the initial point. So in this case, the displacement is 0. So as I said before, distance can never be 0. It always has to have some certain magnitude, constant magnitude, but displacement can be 0. So from this point, one kind of formula, one kind of key point can be inferred, that is distance divided by magnitude of displacement is greater or equal to 1. You need to remember this. You may even get some MCQs or some short questions on this point. Okay. So the second term that we will come across this motion chapter is speed. So what is speed? To give again, I like to take the example of car, so I will again like to take the example of car only. Suppose the car has travelled from point A to B. Now, I will like to, you will always get certain, you will come across certain sentences that a car has travelled or a car is travelling at a speed of 15 km per hour. Now, what does these sentences or what does these words even mean? This means that the formula of speed is distance travelled by time taken. This means that the car has travelled a distance of 15 km per hour. Per hour means 1 hour. Okay, so this is what speed is. The SI unit of speed is meter per second. You can also write this as this way. You must have learned this in your maths class. So this is the SI unit of speed. Now speed, just like we studied previously that distance is a scalar quantity, speed is also a scalar quantity. Okay, I hope till now the scalar and vector points or the terms are clear to you. Now the second term that we will face in this motion chapter is velocity. What is velocity? Velocity is displacement by time. Just like in displacement we had a magnitude and direction, similarly in velocity also we have a magnitude and direction. Now how can I say this? You can also give a very common example, I guess. Till now you have it in your brains. So in case of velocity, we can say that a car travels at a speed 10 km per hour at north. Now when I add this, then it becomes a vector quantity. Okay, so this becomes a vector quantity. So whenever I add a direction, I said it becomes vector quantity. Some other examples of velocity are, suppose a boy starts from a certain point and he reaches to another point. I may say that the boy has travelled a distance of 5 km east and then he has travelled 6 kilometers north, and again I may say that the boy has travelled 7 kilometers east. So whenever I am adding per minute or per hour, whenever I am adding certain directions, then this becomes vector quantity. Okay, so we will go straight into types of speed now. Just like motion had 3 types, speed also has 3 types. The types are uniform speed, non-uniform speed, and average speed. What is uniform speed? When any object travels equal distance in equal time, then it is known as uniform speed. Equal, the key points to this term is equal distance in equal time. Okay. Now for example, I say that a car travels 5 km per hour from A to B and again 5 km per hour from C to D. So here we can see that the car travels from point A to point B maintaining a uniform or a constant speed, that is 5 km per hour. Again the car travels from point C to D maintaining the same speed, that is 5 km per hour. So in this case this is a uniform speed. If I go to non-uniform speed, in case of non-uniform speed, it will cover unequal distances in equal time. Okay, the distance becomes unequal, the time doesn't become unequal. So in this case, if I say that the car travels A to B at 6 km per hour and again from C to D 8 km per hour. So it is very much evident from the points or from the facts that it travels at a certain distance from A to B and again from C to D it travels at another speed. So here we can see that it is non-uniform. Now what is average speed? Average speed is the total distance that an object has traveled by the total time. Okay. To take the same example, the average speed of this particular car will be total distance. Now the total distance, suppose from A to B it is 6 meters, 6 kilometers, 6 no, I will like to take 16, and from C to B it is 20 kilometers. Okay. So what will be the average speed? The average speed of this example will be 16 plus 20 by the total time that it will take. The time is not stated right now, but you may take any kind of example. Suppose the car has travelled from 6 to B in 60 minutes, and again the car has travelled from C to D in 40 minutes. So in that case, we will take the total time. This was a mere example of average speed. Now again you need to keep in mind about the device that measures speed in case of any kind of vehicle. The device is known as speedometer. Okay. Speedometer is fitted in any kind of our vehicles that measures the speed of a moving vehicle. And the device that is known as odometer, this device measures the distance. This is also fitted in our vehicles. You may notice in front of car or in front of any bike or anything which you are going to travel by. This measures speed. Okay. So till now we have come across certain terms. The first one was motion, the second one was types of motion, then we came across distance, displacement, and we also went into depth of speed and velocity. Okay, there's another thing about speed, that is instantaneous speed. What is instantaneous speed now? Instantaneous speed is the speed of any particle or any object at any moment of its journey. Speed of an object at any moment of its journey. Suppose an object is rotating, okay, rotating in a circular path. Any kind of object is rotating in a circular path. What will be the instantaneous speed of this object? In maths you will study that instantaneous speed will be the point, and we can find it out with a tangent. If you don't want to understand this way, I can also give you an example of a normal rectilinear motion. Suppose the car is again travelling from point A to point B, then the instantaneous speed in this whole journey will be just in any kind of case. Okay, suppose this is the whole distance. If I say that what will be the instantaneous point at this time, then you will take this any kind of particular point, any kind of particular instance of its journey will give me the instantaneous speed. We will understand this when we will go into sums. Okay. Now the final point that we are going to study in this video is acceleration. Before I make you understand acceleration, just keep in mind acceleration's SI unit is meter per second square. How does this come? Till now we studied that velocity or speeds SI unit was meter per second. Right? How did suddenly this square come? This square came into the action. You must have studied by now derivations. I guess so. So what is acceleration? Acceleration is when I derivate velocity with respect to time. What is derivate actually? Suppose this is the velocity, this is the whole velocity. Derivate means when I take instances, when I divide it with respect to time, any parts of its motion, then it becomes acceleration. Okay. So acceleration is again a vector quantity. Since I am derivating velocity, it has to have the vector quantity only. There are again three types of acceleration, not three types, there are two types of acceleration. One is a positive acceleration and another one is negative acceleration. What is positive and negative acceleration? Positive acceleration is when this acceleration keeps on increasing with its motion. For example, suppose a car has started from point A to point B. So in its course, suppose there are certain between points. Okay, suppose till now we used to just take only A to B, but now we will take some between points also. Suppose some between points are C and D. Now the car has traveled from A to C at a certain acceleration of 8 meter per second square. Suddenly the car speeds up, okay, increases its speed and it travels at a speed of, suppose it increases its speed and the acceleration becomes 10 meter per second square. And again from D to B, the acceleration increases and becomes 12 meter per second square. So we can see how gradually it is increasing its acceleration. So when the acceleration is on its increasing path, then it is known as positive acceleration. Okay, and when it gradually decreases, then it is known as negative acceleration. Till now I guess you all are able to visualize what is negative acceleration. Suppose the car started with 8, it gradually became 6 and now it became 4. So it is gradually decreasing its acceleration. This will be termed as negative acceleration. Okay. In case of positive acceleration, we do positive, that is the plus in sums, and in case of negative acceleration, we give a negative sign. Now, some certain examples are, if I, okay, so till now just keep in mind the car sums. When we will go in sums, we will understand more in depth. Okay, so I hope till now it is clear to you all. In case of any queries or doubts, please contact the number given below. And please don't forget to like, share and subscribe this channel, that is Prodigy Educlasses. And also in case of you face any doubts or queries, don't forget to comment as well. We are always there to reach you. Thank you.